LeetCode question number 139, word breaks. This is medium question. Let's get into it. Yeah, it has a lot of sum up. Okay. Given a non-empty string S and a dictionary word dig contain a list of non-empty words, determine if S can be segmented into a space-separated sequence of one or more dictionary words. Note, the same words in the dictionary may be reused multiple times in this segmentation. You may assume the dictionary does not contain duplicate words. Okay, let's check with example 1. S is lit code, so we can divide the two things. Lit here, code here, so return true. Next, apple, pen, apple. So apple here, pen here, so return true. And then last example, we can split cat, sand, oak. Wow, there are no oak, okay. Then we can also split cat and oak. No, so return first. How are you gonna do that? Okay, today I would like to start with the DP approach. So first, I would like to show you top-down approach. DP top-down approach is use DFS with memorization, and then after that, I will convert it to bottom-up approach. So my approach is first I will traverse the S, and then when I found the words in word dig, same as word digs, I will split it, and then split left side and right side, and then I will call DFS recursion and then pass right side to argument of the recursion, and then find and then split find and then finally if right side is empty, I will return true. And if we couldn't find any right side as empty, at that time we return first. Does this make sense? Okay, so let me summary my approach. So first I'm gonna use top down DP, that is DFS with memorization. So in this case, first while traverse S, split to purge, and then if left purge in word dig, and DFS right purge, and then I'm gonna return true. Then if we could not find any return value, return first. At this time, I use the memorization. If we do not use memorization, maybe our worst case is that maybe we split 2 by 2 and then using DFS is time complexity must be equal to the n. But in this time we are gonna use memorization, so it changed to n square, and then space is we're gonna use system stack of recursion, and then also we are gonna use memorization, so we go n. And then bottom approach also same. But bottom up approach maybe we do not use system stack because we do not use DFS. So bottom up is a little bit faster than top down. Okay, first let's implement the code. First I write the calculate the length of n, s and n, and then make the word set, because in this case, if I find in the item in list, it takes the linear time. So I would like to change it is word list to word set to make it constant. And then, okay, now it's time to make DFS. And then I pass start index. So if start is n, is I return true. That means start, and then after we going here, and then start is empty means there are nothing. That means all of this letter is consist of word disk. Does this make sense? Yeah, and then like I will traverse is in range start and n plus 1, because we needed to include n. So the region is this one, as we use start and n, and then this n is does not include, right? So that is a region. If we do n plus this one include, and then we need it to n plus 1. So this one in word set, and DFS and is true, and then I return true. If we do not find, and then return first, and then finally I will call DFS from start index. Okay, fix a typo. Okay, looks good. Maybe it gonna meet the TLE because we do not use memoization. So we're gonna use memoization, and if start in memo, I return memo start. Otherwise, we need to calculate memoization. So, and then if the return true is this one is true, and then if we not find, this one must be first. All right. Okay, cool. And next, I'm gonna convert it bottom-up approach. This one is the same. Time is equal m square, and space is also equal n, because we gonna use DP table. So first create a DP table, size n plus 1. And then next is read first, and then dp0 must be true. The region is I'm gonna make like this. So dp is I'm gonna make first 1, 2, 3, 4, 5, 6, 7, 8. So this is 1, 2, 3, 4, 5, 6, 7, 8. And then 0, 1, 2, 3, 4, 5, 6, 7, 8. So the region y is true. And then when I iterate to s, and then if I find the characters, this one, if it is on in the word disk, I will check this one in word disk, and then start minus 1, that is 0. is true, that means this 4 is true. That means until here, everything is valid, right? And then next I will check from here, from here to here. At that time, I also able to code is in here, right? And the start is 5, right? So 5 minus 1 is 4. This one is true, then this one also true. That means we already find the valid cases. So return dp minus 1. That is final. That is the. Does this make sense? Okay, cool. So okay, first and then let me calculate the length s, and then same way. Word set is set word dix, and then make the table first and plus 1, and then next I would like to start in range n, and then for n in range start plus 1 and then n plus 1. Not n plus 1, n plus 1. And then now I'm gonna check if s start and end in word set and dp start is true, and then yeah, and then I will dp end is true, and then finally I will check dp minus 1. Alright. Okay. Let me check one more time. N is S, word is word dix. What the dix is correct, and then dp. I forgot. dp first must be true. Okay, looks good. Thank you.